Git thinks about data. So instead of this sort of thing, it looks more like this. I think it's a simpler format, but it's easier, I think, to use Git in an effective manner if you understand that what you're doing is you're going through and you're creating snapshots. You're saying, here's a snapshot of my project that I want to store, and then be able to share that with people, and then Git figures out everything between those snapshots after the fact. It's not file-based, it's snapshot-based. Okay. Any questions on that first before I go on? Yeah.
In order to actually do meaningful version history, if you are copying and modifying files, you have to snapshot it several times so there's enough information to go you rename and then modify a file, copy and then modify it.
It depends on how much you change it. If it is, did everybody hear the question? It's if you change a file too much and rename it, we'll still be able to follow the rename. And the answer is it depends on how much you changed it. I mean, if you change the file more than, say, 50% or something, what it looks for is content that's similar where a file was removed from one and added to the other for renames. For copies, then it just, I don't know what the exact percentage is, but it does a like Levenstein distance or something on the content to see how similar two pieces of content are, and then if they're similar enough, then it assumes the rename. I think there are ways of forcing it to say this file was a rename, but for the most part, I've never seen anybody need that. Most people, if you're changing it and it's 80% the same, if it's more than like 50% the same, is it really even the same content, right? So, I don't know. If I ever find anybody that actually has had a problem with that, I'll let you know. But generally, it works fine. Yeah?
You mentioned the compression in the tool called GC.
Yeah.
Does when you do a git commit or whatever, does that automatically run GC?
It runs a... I don't remember the exact commands that will fire GC auto, but there is, you can't run just git GC and it will do it right there, right? So it'll take all your files and it'll put them in a pack file and they'll compress them all up and save space and stuff. There are some commands that run a version of that checks to see if it should, and so most of the time, like 99% of the time, it's a no-op. It just checks real fast to see if it should, and which is just seeing how many loose objects there are. If there are too many, then it will run it automatically. It doesn't happen very often. It happens, in heavy use with a big system, it happens once every couple months. Yeah, so it'll do it automatically when it feels that it needs to. It will also do it when you do a push. So when you're actually not necessarily locally, but it will create a pack file to send over the network. So it's using as little of the network as it possibly can. Yeah. All right. And the pull is too, when you fetch or clone from something, it'll do it on the server side and then just send you a pack file, and then you just store the pack file locally. Okay, so first step. So starting to use Git. The first thing that you want to do is you want to set up your configuration options, your username and email. And the reason why you want to do this is because in Git there's no centralized server that acts as an authentication point that says this is your user and then records that data when you're making your commits on the central server. Instead, what you do is you say, this is my username and email address, these are my credentials. All the commits that I'm creating locally are going to be stored with this information as my credentials. And then when I push them up somewhere, somebody can pull from that and say, do I trust this data? Right? So it is a trust-based system on the person that's merging it in. Do I trust that this is the person that they say that they are, and that this work is valid, and then I can merge it into mine, and I trust that that's who that is. So it's up to you on how you want to do this. You could spoof it if you wanted to, but then nobody should accept your work, right? Just like you can spoof email or something. So in this case, you want to set up a username and email because it is what goes into your commits that are recorded, and it's difficult to change later. Git will guess if they're not set, but it's very bad at guessing, as it should be. And so you want to set those up first. The -- global means store these values in my tilde.git config so that they are the default for every time that I'm running. You only have to do this once, right? It stores it in tilde.git config, and then in every Git project you're doing, these are the defaults, and you can override them in individual projects if you want to by running it again without the -- global. And then the other thing you probably want to do if you use command line stuff, I assume most of you use command line stuff, is color.ui so you can turn on the terminal coloring, which is a very nice addition in Git. Okay, so once that's done, you do that once, you're set up, and you're ready to use Git. So getting a Git repository, getting Git. One way you can do it is creating one. How many people in the room have used RCS? It's really interesting. Every time that I do kind of a lot of talks, and every time that I do RCS, I either have one person out of 50 that has used it, and they're like, you just made me feel really old. Or it's like an open source or Perl conference, and everybody's like, of course I use it. So Git's nice because you can use Git like you used RCS, right? I used RCS in college, and I actually liked RCS because you could just go into any directory and say, you know, I don't even remember what the commands are anymore. But you can say git init, right? And now you have a Git repository immediately. And you can start adding and committing your snapshots immediately without having a network connection, without having your repository set up on another server anymore, right? You do not need to use Git in a distributed manner. You can use Git locally only if you want to. I used to version control my Keynote presentations just because Mac would do .keynote as a directory, and you can go in there, get init, and just start version controlling, you know, this weird binary format, and it works fine. So you can certainly do that. You run git init, and what it will do. So if we have a file, sorry about the RV, I apologize. If you have a file, I think I have a Python example in here too. If you have a file and you run git init, it will give you a .git directory in that thing. So we have .git directory and we have our file, and that's all that we have. And this is a Git repository, right? Because of this .git directory. So it's not like Subversion. You don't have a .git directory in every subdirectory of your project. It's not metadata, right? This is your repository. This is the exact data that is on the server if you were to push to a server. In fact, if you tar up this .git directory and put it on a server, then that's now a central Git repository that people can use to collaborate with. Right, that can be the starting point for that. There's nothing in this right now. The other thing that you can do with this is that it doesn't need to be there in the root of your project like that. It is by default, but you can put it somewhere else and export an environment variable that says my repository is over here, and just run your git commands, and it'll find it over there and modify that repository like that. So it doesn't actually have to be there if you don't want it to be. Okay, there's our file. So. Now the next stage is you say git add dot that starts tracking all of your content. So in this case, it's our one file, and git commit -m. So this is all basically the same thing that you would do in Subversion, right? And that's it. We have a snapshot of our project now. Now, if we look at the .git directory, we'll see a couple of things. One is this, which are our objects. So if you remember the sort of example that I did at the beginning, one of these is the commit metadata, so who did it and when they did it and what the commit message is. One of these is the directory listing, so the file name and then the block pointer for the content, and the other one is the content, right? So those are the three objects. You can actually see those. If you run git show on any of these SHAs, you'll see what the actual content of each one is. So you can try this out on your machine. It's kind of cool to go through and see how Git is actually storing this data. And then finally, we have refs heads master, which is our reference, our branch pointer. So if we cap this file, all we'll see is one of these, which is the commit, right? And it will point to the directory listing, and the directory listing will point to the content. So we can walk through all these objects by using this as a starting point. Okay, that's creating. Is there any questions on that real fast? Okay, so that's creating one. The other way that we can get a Git repository is to clone one. So if we were to get clone and we give the URL, there's two URLs that you see most often, starting to become three. One is this git ://. This is an unauthenticated protocol over a special port, over the Git port. It's like whatever body assigns ports. Does anybody know? Thank you. It is that assigned. It's 9418 or something. But that goes over a port. It is unauthenticated and unencrypted. So this is generally used for read-only versions of projects, of open source projects. This is how you get, what's the Perl 6 implementation on? So this is how you get that, right, off GitHub. If you're not a core committer, which I'm assuming there's only 1 or 2 people that can actually commit to that. This is how you actually get it in the first place, right? Is you use git ://. The other type of URL that you see most often is an @ one or SSH : //. They're both SSH based, and so it uses normal SSH. Generally public key encryption, but you can use anything that SSH will use to authenticate. And that's usually used for either private repositories or ones that you can write to. Right? Generally, if the SSH user has write access to wherever that is on the disk, then you can write to that repository as well. So those are the 2 you'll see most often. The third one that's starting to become more popular is HTTP, because there's now a smart HTTP protocol that can do basically the same stuff these ones can, but you can use HTTP-based authentication to do authentication, so you can do basic auth or SSL certs, whatever. So anyways, but if you see git ://, that means read only. So you'll see a bunch of output like this. You'll see this total 591. Remember when we did added the 1 file and committed, we had 3 objects. This one has 591 objects, so it could be either one commit of a large repository, or it's not a very big repo. You look at the Linux kernel, by the way, has about 1 million objects in it, I think. This last time that I checked. So we go into the thing, we have some initial checkout, we can start editing these files and doing commits. And we can edit these files and do a huge series of commits, even though we clone it from a read-only URL, right? We don't have to have write access to any remote repository yet in order to start committing to this. We can find some place to push it later, right? Or we can just create our own and push it there. We don't necessarily need to have write access to that URL ever, but we can get a copy of it and start committing. Okay, so start committing. How do we actually do commits in Git? This is the basic workflow of Git. Can anybody point out the line here that is different than Subversion? You have a 1 in 4 chance. Stage changes, right? Well, possibly review your changes depending on how you code. Yes, it stages changes. You don't do that in Subversion. You can do that in Git. At the very end of this, I'll do one slide that says exactly how you can do the exact same workflow that you do in Subversion, but I want to show the longer one because it can be very useful for crafting good code. So there are 3 different topics in Git that are useful. One is the working directory. What time is it? 3 o'clock already? It's 3:30 that I stopped, right? For the break? Okay. So one is the working directory. The working directory is the working copy of your project. So these are the files on disk, right? This is what you can actually edit. On a server, you don't have the working directory or the index. You only have the repositories. Just the repository there by itself on the server that you can push and pull from. But when you're working on something, when you're actually creating new commits locally, then you have to have a working directory so you can modify the file somewhere. And the repository, which is the object database, is actually where the objects go when you've written new snapshots. And then finally, there's a middle ground. There's a staging area. And the point of Git is to put in your staging area what you want your snapshot to look like, and then record that snapshot, right? So this is how we do this. We edit the files. First, you get some checkout by doing a clone or by creating some files in a directory and running Git init, but you have a working directory of files. So in this case, my Python example, I'll have this is a Google App Engine app, right? So if I have a couple files and I go into this file and I add a comment and I run git status, then I'll see that that file has been modified, right? Git will tell me this file is changed on disk from when you initially checked it out. And that's cool. And changed but not updated means changed but not staged. It means I haven't staged the change to this file yet. When you run git commit, generally, it will not look at your working directory. Git commit completely ignores your working directory. It does not care what's in you can remove all the files in your working directory. It doesn't give a shit, right? It just doesn't care. What it looks at is your index. So once you put this in your index, and when you run git commit, it will record that. Right now,